Hi, this is the first of two videos on frictional forces, and it relates to Young and Freedman's University Physics Chapter 5, Section 3. So let's dive right in. So contact forces. What are contact forces? Contact forces are the forces that relate to two bodies that are in direct contact, or two bodies that are touching, as it were. So you know the normal force. The normal force is the force we refer to as the force that pushes back up as our weight pushes down. So we call this the normal force, the upward force from a surface on which a body is placed. This is why we don't fall through the floor, because the floor is, as it were, pushing back up on us in an equal way to the force that our weight is pushing down. But there's another contact force that's very important, which you've encountered, no doubt, in your life, and that is frictional forces. This is the source of rug burn. Anyway, we want to talk about frictional forces in this particular video. So there's the kinetic friction force. So the F there means force, little k stands for kinetic. And it, of course, has a direction, which is what that little vector notation over the top means. So kinetic friction force is the kind of friction that acts when a body slides over a surface. I know if we could get down really small, we'd see that this is actually a result of electromagnetic interactions between the two things that are touching each other. But we don't experience it that way in our big selves. So kinetic friction is the kind of friction that acts when a body is sliding over, a surface. Now, in many cases, that force is going to be proportional to the normal force. That's always perpendicular. So depending on whether you're even if you're pushing it up, if you're pushing it up a hill, pushing it down a hill, the normal force that we're talking about is perpendicular to it. But it tends to be proportional. And scientists long ago, centuries ago, realized that mathematically we can express a proportional situation as basically a situation like this. So the kinetic friction force, if it's proportional to n, the normal force, if two things are proportional, then we can actually equate them mathematically by interjecting a constant. And the constant in this case is mu k, which stands for the coefficient of kinetic friction. That's a constant. So basically, and there's a chart in this section of the book of different kinds of coefficients, constants, for different kinds of objects. So depending on the material, you'll have a different coefficient of kinetic friction. If it's easy to slide the material over something, then it's going to have a very small coefficient. But the harder it is on a particular surface to push it, the larger the coefficient is going to be. Anyway, so mu k is the coefficient of kinetic friction, and we can say that the amount of friction force pushing back on something that we're pushing, so we're pushing something across the floor. The force with which, as it were, friction is pushing back is going to be this constant times the normal force. Okay? That's the kinetic friction force. We can also speak of a static friction force. So we have a little s standing for the static. F stands for force, and the arrow tells us it's a vector, has direction. So static friction force is the kind of friction you have to overcome to get a body to start sliding across the floor. We've experienced this, something heavy, we're trying to get it going. It takes force to get it started. Once it gets going, it takes less force. The kinetic friction force, once it gets going, it doesn't take as much energy to keep it going. The static friction force is the amount of force you have to get it to start sliding across the floor. And once again, that critical force, as it were, is approximately proportional to and perpendicular to the normal force. And so we say that the force that pushes back, keeping you from moving it, so the force that you need to use to get it going is basically the force of the static friction is going to be less than that. So if you can get it going, that's going to be the static friction force, Fs, is equal to, here's another constant, mu S. Mu S is the coefficient of static friction. It's a different constant than the one for kinetic friction. But when you're just able to get it moving, that's going to be just a little bit more than the force of static friction, to get it moving, you're going to have to do just a little bit more than this constant times the normal force. So if you can't get it moving, then that force that is exerted is less than or equal to this number. Now, once you get to that number, mu sigma n, normal force, once you get past that number, then you're going to be able to move it. But any force less than that is going to keep you from moving it. Okay, let's say you want to move it at a constant speed. So we can speak also of a coefficient of rolling friction, mu r, that is the amount that relates to the amount of force needed to keep it moving at a constant speed. Movers sometimes call this the tractive resistance, having to do with the amount of force that you have to use to keep it moving at a constant speed over a flat surface. Okay, well, there you have some information on coefficients of kinetic, static, and rolling friction. The next section is on fluid resistance.